Welcome to CBS Easy.
Have you ever thought that math could be a secret weapon for solving real-life mysteries? Well, it can. Today, we're going to take a simple puzzle from a day at the fair and crack it wide open using a little bit of algebra. Let's get right into it.
Okay, so meet Akila. She went to the fair, had a great time riding the giant wheel and playing a game called Hoopla, but she left us with just two little clues. First, the number of times she played Hoopla was exactly half the number of rides she took, and second, her whole adventure cost a grand total of 20 rupees.
And that's our mission. With just those two little breadcrumbs of information, can we actually become mathematical detectives and figure out her entire day? You bet we can, and we're going to do it together. All right, first things first. Let's lay out all the evidence we have from this puzzle at the fair.
So, let's get this straight. We've got two main conditions here. The first one is all about the number of things she did. The games are half the rides. The second clue is all about the money. Each ride was 3 rupees, each game was 4, and it all added up to 20. These are the facts of our case.
Now here's where the magic really begins. We need to translate these clues from plain English into the language of math. We're essentially writing a code to solve the puzzle.
To do that, we need some placeholders for our unknowns. So let's say X is the number of rides she took, and we'll use Y for the number of Hoopla games she played. Simple enough, right? And just like that, our clues become code. The first clue, games are half the rides, turns into Y equals 1/2 X. And the second clue about the money? Well, that's 3X for 3 rupees per ride, plus 4Y for 4 rupees per game, and that all equals 20. And look at that. We've just created what's called a pair of linear equations in 2 variables.
So we have the code. How do we crack it? Well, our first tool is actually a visual one. We can literally turn these equations into a picture and just see the answer.
Here's the deal. Any linear equation can be drawn as a perfect straight line on a graph. So, with 2 equations, you get 2 lines. And the solution, the one and only answer that works for both equations, is the exact spot, the XY point, where those 2 lines cross.
Now, when you draw 2 lines, only 3 things can possibly happen, right? They can cross at one single point, which is what we're hoping for. They could be parallel, meaning they never ever touch, so there's no solution. Or they could be the exact same line, just lying right on top of each other, which means there are infinite solutions.
Okay, and check this out. This table is basically a mathematical crystal ball. Seriously. Just by comparing some numbers from our equations, we can predict if the lines are going to intersect, be parallel, or be the same, all without ever having to pick up a pencil and draw the graph. It's an amazing shortcut.
But you know, there's a problem. This visual method, as cool as it is, has one major flaw.
I mean, what if the answer isn't a nice, clean, whole number? What if the lines cross at a messy spot like 4.2 rides and 2.1 games? It's practically impossible to read that accurately off a hand-drawn graph. For that kind of precision, we're going to need a much more powerful tool.
And that tool is a purely algebraic method. It's called the substitution method. This is how we solve the code with pure logic, no pictures required.
The process is actually pretty straightforward. First, you take one of the equations, and you just get one of the variables by itself. Then, you take what that variable equals, and you substitute it into the other equation. It's like a swap, and this move magically makes one of the variables disappear, leaving you with a really simple equation you can solve in a snap.
And what's really neat about this method is it has a built-in detector for those weird cases we talked about. If you're solving away and the variables suddenly vanish, leaving you with something true like 18 equals 18, that means you have infinite solutions. If they vanish and leave you with something totally false like -4 equals 0, you know for sure there's no solution at all.
So now we've got our super precise tool, let's head back to Akila's puzzle and finally, once and for all, crack this fairground code.
Okay, our 2 lines of code are back on the screen. The first one connects the number of rides and games. The second one connects their costs. Time to put the substitution method to work.
Now, this is pretty convenient. The first equation already has y by itself for us. So we take that expression, 1/2 x, and we literally plug it into the y spot in the second equation. That gives us 3x plus 4 times 1/2 x equals 20. A little bit of cleanup, and that simplifies down to a beautiful, simple 5x equals 20.
And from there, it's just one tiny step. Divide both sides by 5, and boom, we have the first part of our answer, x equals 4. We now know that Akila took 4 rides.
But hold on, we're not done yet. That's only half the code.
We take our answer, x equals 4, and we pop it back into that super easy first equation. So y equals 1/2 times 4. And of course, that gives us our second answer, y equals 2.
And there you have it. The puzzle is solved. Akila went on 4 rides and played 2 games of Hoopla. Everything fits her clues perfectly. Case closed.
You know, this method is so much bigger than just figuring out a day at the fair. It's a whole new way of thinking. Think about it. From trying to balance a budget to planning a trip, so many problems in our lives have a couple of conditions that both need to be true. So the real question is, what puzzles in your life are just a pair of linear equations waiting to be solved?
Thank you for watching with us. See you next time.